All right, I'm showing 9 o'clock, so let's go ahead and get started. My name is Mike D. Lecluse. I'm the president of Lesman Instrument Company. I'd like to thank all of you for taking time out of your busy schedule to join us for Fixed Gas Detection 301. So it's the next step in the 3 series, and it'll give you some ideas on maintenance and troubleshooting. Today, Charles Simek of Honeywell Analytics is going to present. This webinar will dive into the troubleshooting tips and maintenance best practices for fixed gas detection applications. We're going to cover some topics like inspecting your gas monitoring equipment, some cleaning calibration, the maintenance, and then the care and feeding of transmitters and optical devices for gas detection. Charles has worked in the industrial fire and gas detection safety industry for 30 years, serving as an electronics technician, technical writer, sales manager, business development manager, and product specialist. He's also been a member of the NFPA Building Safety Section for the past 14 years. Currently, Charles is a subject matter expert and product technology specialist for electro-optical flame detectors and working for the Honeywell Analytics marketing team on their premium line of fixed gas and flame detection equipment. We will be muting the phone lines. If you have any questions, there's a question tool built into GoToWebinar. Please just type in your question and I'll make sure they get answered. With that, I'll turn it over to Charles.
Thank you, Mike. So today I'm gonna provide some support information, basically telling you where you can go to get additional information. We're going to talk about inspections and establishing schedules. We'll go over some basic cleaning routines. We'll talk about calibration. Then we'll jump into maintenance. Talk a little bit about optical devices because the above items are going to be a little bit different for them. And then we're going to close out with a discussion on transmitters. So if you need support information from Honeywell, I've provided several links here, phone numbers and email addresses. The top number is for customer service. If you have order status, pricing, and availability questions, you'll use that phone number or use that email address. Similarly, for product selection and application support, this is generally pre-sales support. Then we provide a technical support line, generally after the product's been installed and you have questions about its operation or some of its functionality. You'll call that third group there. And then for product returns, repairs, and warranties, you'll contact HAU service. And then we have a couple of separate numbers for our Ray systems. Specifically, the only Ray instrument we're going to talk about today is the RayGuard 2 PID. And the second from the bottom is technical support. And then likewise, for repairs and returns and warranty, you'll use that bottom number. So when we talk about inspections and scheduling inspections, basically you're wanting to maintain the lifetime of your product. And so you should establish a regular schedule of visual inspections and then adopt some remedial actions based on the observations that you have. Okay, so generally you will establish a quarterly routine. And of course, the frequency of the inspections is going to vary by the site. A cleaner site is going to require fewer inspections, whereas a dirtier site or a site that has more dirt, you're gonna want to maybe inspect it more frequently. It's important to keep a log in the date and the time of the inspections, and also to put any comments, anything that you think is relevant to your inspection. Okay, so a visual inspection should include in the junction boxes, and this is all about cabling and wiring. What you want to verify is that the cables are not compromised. You don't have any bare exposed conductors that are leading to the outside world, or that the cable shield hasn't been compromised, because this can introduce transients onto your power and to your signal lines, and that kind of can up the quality of the detector. Also, check accessory items. Look for breaks, tears, cracks, or excessive wear. If you notice any of these, make a note to change that accessory item out. Also, the most important part is to make sure that the sensors have a clear and unobstructed gas path so that we can actually detect a hazard. So during periodic inspections, sometimes you'll be asked by your managers to go out and challenge the sensor or verify its operation. And generally, this is considered a bump test. It's not a calibration. It's just a procedure that you'll use and you'll adopt to go out and actually challenge the sensor to make sure that it's responding to gas. One of the things that you want to be aware of under normal conditions for the field device, if you challenge it with a gas, make sure you inhibit the outputs. Otherwise, you possibly could send an alarm to the control room or activate other executive actions that might cause a shutdown or something, and you don't want to do that. Again, when you do bump testing, similar with inspections, keep a good and accurate log of date and time and any any remarks or any irregularities that you might witness during that bump test. When it comes to calibration, we'll go ahead and say that a lot of our optical devices, like the Searchpoint Optima Plus, the Searchline Excel, flame detectors, and also our Search Zone Sonic, which is a newer device. It's an ultrasonic gas leak detector. Generally, they don't require frequency once they're installed in the field. We do have an exception for the Optima. When you have an Optima that you've installed and you want to change the target gas that you're sensing, when you make that change, you need to recalibrate the instrument with the new target gas. Okay. All the other field devices, catalytic bead sensors, the PID and the Rayguard 2, and then the electrochemical cells, these are consumable products, and so we need to establish routine calibration schedule. And again, with bump testing and inspection, keep an accurate log, date and time responses of the calibrations, and put any comments or marks that you think are relevant to that action. Jumping to cleaning, basically based on your visual inspections that we previously discussed, you should, again, ensure that the gas path of all sensors is clear of obstructions and contaminants. When it comes to flame detection, this is an optical device, and so its primary maintenance item will be to make sure that the window is unobstructed. It's free of contaminants. It's not dirty. Flame detectors are line of sight devices, so they need to see that flame. And so if the window is obscured, it compromises the detector's ability to do that. That's true with other optical devices also, such as the Searchline Excel and the Optima Plus. And that, again, it holds true for the Search Zone Sonic, which is our acoustical gas leak detector. So when it comes to actual cleaning, so the gas path, if it's blocked or obstructed, it's going to inhibit the ability of gas to actually get to the sensing element. Okay, when we talk about electrochemical cells or catalytic bead sensors, we don't want to use an alcohol. We do want to use alcohol and other hydrocarbon-based. Well, If you use if you use alcohol and other hydrocarbon-based chemicals, you may cause the sensor to go into alarm if it's not inhibited. And so it's important if you're going to be using those to inhibit the output during cleaning. When we look at transmitters, its number one thing is because it's a display, and it's a display that provides status and gas detection levels. We want to make sure that that window is clean so that we can actually see that. Okay, so when calibrating gas detectors, there's some hard and fast rules, general rules that we like to follow. Always use the proper calibration accessory. Don't use the bump test kit to perform a calibration because it's not providing a good enough seal to allow the gas to flow through. It's more of a go, no-go test on bump testing. But when you're calibrating, you're trying to give the detector an accurate measure of gas so that we can actually adjust the response of the sensor if necessary. But that gas needs to be absolutely, we have to have a nice steady concentration there. Always refer to the product manual. So for zero calibrations, as a general rule, we say never assume that the background is free of contaminants. So you can use zero air to basically eliminate any contaminants that are there. So use a zero air during the zeroing part of the calibration, or you can use a calibrated reference like a portable gas detector, and basically you'll hold that near the sensor, the fixed point sensor, and you'll see if you can detect any contaminants that are present. Honeywell has a very good 4-gas detector. It's CO, oxygen, H2S, and LELs. And so that's always a good detector to use when you're in the field, when you're trying to verify the background is contaminant free. So when we go to the span calibration, we always want to target with the span gas, with the actual target gas. We want to calibrate with the target gas that we're expecting to see in the environment. The only exception that I have to this is on the Regulators 2. We always calibrate with isobutylene, and in the gas measurements window, we can actually set the correction factor for the gas that we're actually trying to detect. The reason we use isobutylene on the Regulators 2 PID, it's a gas that doesn't deteriorate very easily over time, and so it has a very long shelf life. It's a very consistent, very stable gas, and it's also readily available, which means it's not super expensive. So most of the detectors are going to use 50% of full scale. So if you are calibrating a combustible gas sensor, you'll use 50% LEL of whatever the target gas is. Most cases, that's methane. Some of our instruments, though, do allow you to use a calibration gas that is anywhere between 30 and 70% LEL. One case that I know of on the Optima, you're allowed to use 100% of the full scale. That's on a specific unit, though. It's not the standard unit. And then again, always consult the product manual for details. Again, when calibrating gas detectors, the flow rate of the gas is important. And so I've listed the different regulators here when we're using electrochemical cell sensors, or when we're using catalytic bead sensor or the infrared. The photoionization detector, which is the Regulators 2 PID, has an internal pump. And so we don't generally flow gas. We use what's called a demand flow regulator. So that pump is going to draw the gas as it's required during the calibration process. So inspections and cleanings are forms of preventative maintenance to ensure proper operation and long product life. Beyond this, we have other maintenance tasks. One of the most popular ones is changing out the sensor. When it comes to the catalytic bead sensors, electrochemical cells, and even the sensing elements on the Rayguard 2 PID, again, these are consumable products. And so they'll have a specified lifetime. When that lifetime expires, it's necessary to go ahead and replace either the sensing element or the complete sensor cartridge. So in order to do that, on the Series 3000, which is our low-end 2-wire transmitter that we use for toxic gases, I kind of have a display here that shows you the critical elements. We show this the actual transmitter, the sensor base, the cell, and the cap. So the base, the cell, and the cap all make up what's called the sensor body. And you can get to the sensor body by removing the weather protection and then unscrewing the sensor retainer, and you'll be able to pull that whole sensor body out. You can either replace the entire sensor body with another one, or you can unscrew the sensor cap and actually pull that element out and replace it with another sensing element. Again, the electrochemical sensors, that's generally what these cells are. They have a shelf life, and so you're supposed to use them within the expiration date that's listed on the container when you actually purchase it. Similarly, on the XCD, you cannot get to the sensing element. The only thing you can do is pull the cartridge and replace it with a new cartridge, which is the complete sensor body. We show the transmitter on the left, or sorry, on the right, the yellow, and then just beneath that we have the sensor cartridge. There's the sensor retaining ring, and then the weather protection beneath that. In all cases, make sure you've got power turned off before you switch out sensors. So on the XCD, the toxic and oxygen sensors, we use what's called a sense point sensor. On the XCD, we also use the sense point flammable sensor, which is catalytic bead. And you can actually get to, if the XCD contains the sense point, it's a black body sensor. You can actually get previous slide. You have to replace version. You can actually gain that and replace. Do a sensor to replace in order to values are accepted. This is for the remote flammable. So you have the XCD transmitter itself mounted about eye height, right around that 5 to 6 foot level, and then you may have this flammable sensor mounted up very high or very low, and it's accessible, but you wouldn't want the transmitter down there with it. You want the transmitter where it's easily accessible. So on this, you will remove the weather protection and the sensor retainer, and you'll pull the cartridge. And likewise, if you have the sense point flammable detector, you'll be able to pull that sensing element out and replace it. Otherwise, you just have to replace the cartridge here. And this shows the RTD. You've seen this picture before on a couple slides back. RTD is remote toxic detector. RFD is remote flammable detector. So X and X, we have a couple of different options. So our X and X is our universal transmitter, and every field sensor that we make will connect to the X and X. And so we have a variety of different replacement procedures. The MPD sensor is very easy to replace. You unscrew the cap, and the sensing element is on the inside. The MPD sensors are multiple purpose detector. The one that we show here is either a catalytic bead or an IR cell. Okay, and so you'll just pull that little cell out and put the new one in, close it back up, and recalibrate, and you're good to go. This shows it with our typical electrochemical sensor. This shows the one where the arrow coming down and to the left shows you pulling the sensor out, and then the one with the arrow going to the left and up is telling you to insert where to insert the new sensor. Below that, we have the weather protection and also the retaining cap or the retainer. So after you replace all of that, the sensor warm-up is going to begin, and the screen's going to alternate between fault 151 and warm. Once you recalibrate that message will go away. So once you pull the sensor cartridge out, as shown here, the two little bodies that are separated, once you pull the sensor cartridge out, you can gain access to the actual cell element by removing the sensor cap, just like you would on any other on the Series 3000. Okay, so you can have access to the sensing element. You can replace it that way. We have a newer product. It's called the SensePoint XRL, and it uses a Bluetooth app in order to provide maintenance. Okay, so the maintenance that we're going to talk about here is obviously replacing the sensor. And so this is our ready screen, the one with the current reading. We've got a green circle around a 0, which is our gas concentration, and then it says above that, it says CO normal. CO would be the target gas that the unit's calibrated for. So by selecting the maintenance button, we'll open up the maintenance screen. And from the maintenance screen, we want to select change sensor. Okay, so now the app is going to prompt you to remove the sensor on the next screen. The screen will come up and it's going to tell you remove the sensor. Okay, so on that, what you're going to do is you're going to loosen that little locking screw, pull the trim ring off, and then unscrew the sensor cover, and you'll be able to out the new one, the sensor trim ring. Okay, then you'll hit next, and it's going to prompt you to go ahead and calibrate. So when you hit the calibrate button there, you'll basically be in a position to zero the instrument and give it a span. So Rayguard 2 PID, it's a little bit more maintenance intensive, let's say. Okay, so when you want to change, you simply hold the magnet over the triangle with the plus on top, the triangle that's pointing up, and you'll hold it there for 3 seconds, and this is going to bring up what's called a change sensor display. Okay, it's very important that you do not hit go at this time. What you're wanting to do is the instrument is telling you at this point, I have removed power from the intrinsically safe barrier, so now you can remove what's called the DIGPID, which is the cylindrical device off the bottom of the transmitter. And so you'll turn this clockwise to remove it from the module, or to remove the module from the IS barrier, which is connected to the transmitter. So when you do that, and you're about ready to reinsert your new DigiPID, it's very important that the 2 ports and the 1 connector are lined up. If you somehow pinch one of those pins, your unit is not going to function properly. And this is like really important. Yeah, I can't overemphasize the importance of making sure that those 2 ports, one's the inlet, the other's the outlet, and that connector, it's an 8-pin connector, all line up and are connected correctly before you actually turn the fastening nut back on. Once you've done that, now you can hit the go, which is directly above the triangle that points down and with the minus key above it. And then you'll be prompted to recalibrate the digipid with isobutylene. When we get into optical devices, I list 3 here. We have 4 optical devices. One we've already talked about, the Regard 2 PID. We have also the SearchPoint Optima Plus. We have the Searchline Excel. The Optima Plus is a point IR hydrocarbon gas detector. So the gas needs to diffuse to that point in order for it to be sensed. The Searchline Excel is an open path IR hydrocarbon gas detector. So if we get gas migration between the receiver and the transmitter, which can be up to 650 feet apart, we'll be able to detect that gas if the concentration and the cloud is big enough. The other optical devices are flame detectors, and we're going to talk about those a little bit later. So SearchPoint Optima Plus, again, can't reemphasize this enough. It needs to be inspected periodically. You remove the weather protection in order to get at the detection chamber. Where the IR sources and detectors are and the reflective window, they're behind what's called dust barrier, and it's a little rubber and gold screened item that can be pushed in and pulled out. So you would remove the dust barrier, and then with either a cotton bud or a soft cloth, using a very, very mild detergent. Do not use alcohol or a hydrocarbon-based solvent because that's what the detector is looking for. It's looking for hydrocarbons. So you'll just clean off the surface of where the mirror is, and also the surface where the window is, where the source and detector are behind. Go ahead and replace the dust barrier and the weather protection. Cycle power to clear any faults, and then maybe inhibit the unit and bump test it just to make sure everything is functioning properly. Searchline Excel, its biggest maintenance item is going to make sure that the windows are clean. Now we have an accessory item. It's called the SCH1. It's a handheld interrogator, and you can actually clip it on to a couple of the connections for the Excel, and it gives you internal access to how the Searchline Excel is operating. Okay, so the signal output's going to vary during cleaning because you're interrupting the optical path. Excuse me. And so on the Excel, on the actual handheld unit, you're going to select display from the calibration menu, even though you're not calibrating. Okay. Then you're going to clean any dust and dirt from the window. Again, don't use alcohol or a hydrocarbon-based solvent. Use soapy water with a soft cloth. You can press escape to return back to the main menu on the SCH1, and then you can also use that handheld interrogator to re-zero the unit. Anytime you make an alignment change, or anytime you go and perform a cleaning or maintenance operation, it's important to re-zero the Excel so that it accepts the new information. If you had dirty windows, it's going to change the source intensity received at the receiver. So it's important to re-zero the instrument so that the instrument understands, okay, look, I'm seeing the correct value of energy coming from the source lamp. Okay, so after FS20X and 24X detectors are installed and commissioned, there's not a lot to do. Again, we recommend performing end-to-end testing at least annually. Again, that's going to vary according to the application and the environmental conditions. it's important that when you do an end-to-end test, that you can prove you can activate the solenoid, which is going to cause suppression, but inhibit the output that actually releases the suppression, because you don't want to release suppression during a live test or just a test. Using the test lamp, you can basically verify the integrity of the detector. Just remember that the test lamp is not a 1 square foot fire. All it is it's a source of radiant energy that the detector will recognize, and you can use it to verify that the detector has an unobstructed view of the threat area. If your threat area is 100 feet away, don't think you can take the test lamp 100 feet away and test it. The test lamps are good between 10 and 25 feet. So you have to get between your coverage area and where the detector is in order to adequately test the detector. I don't think anybody has a very long range test lamp. So when we're talking about cleaning the windows on the FS24X, which is our triple IR detector, there is no grill that goes across the face, so access to the window is very easy. When we talk about the UVIR or the FS20X, we have a grill across the face to protect the industrial quartz window. And so you'll need to loosen one of the screws on the housing lid and open that grill up swing it open like a gate. That give you access to the entire window surface. It's also important to clean the back side of that grill that faces the window, because that grill is part of our functional self-check that we do on the FS20X. And so if the windows are dirty or the grill is dirty, it may compromise that test and cause the detector to go into fault. That fault generally tells you, come out and clean your windows, come out and clean your optics. Okay, test lamp. We've talked about a little bit about this on the previous slide. So you want to make sure that your optical path is free of obstructions, that you have a clear sight to your threat area, and basically a detector that is aimed correctly at the threat area. The only way we can do a functional test without lighting a 1 square foot fire, especially in a hazardous area, is to use a test lamp. So to disable outputs that would cause executive actions to occur. You don't want to evacuate a building during a test. You don't want to dump suppression during a test. So generally you'll disable the outputs. You'll aim the detector at the front of the test lamp, try and be on axis as much as possible. If you're off axis a little bit, it shouldn't be too bad. The further off axis you are, the closer you'll have to be to the detector. So the distance, like I said, is between 10 and 25 feet. If you're within 10 feet, you may be dumping too much what's called visible energy onto the sensor array. And when our detectors see too much visible energy in relation to what a real fire is, we'll typically reject it as a false alarm source. And so the test lamp might not be effective at testing the functionality at distances shorter than 10 feet. Simply press and hold the test lamp's push button and watch for the alarm LED on the face of the detector to start flashing red. The location of this LED is going to be near the top of the window. If the detector does not respond within 30 seconds, there's a couple of things you can do. Number one, make sure you've got a fully charged test lamp. Number two, make sure that your distance that you're testing is correct. A lot of times, if you don't have a fully charged test lamp, you need to be a little bit closer to the detector. And verify that your testing technique that we've described above is being followed. If the detector still doesn't respond, you'll probably have to contact Honeywell and have a service guy come out, or maybe send the detector back in for evaluation and repair. Transmitters. Okay, so we have 3 product lines that we list under transmitters. We have the Series 3000, We talked about sensor replacement for all three of these. We have the XCD, which includes RFD and RTD, and then we have the XNX. For troubleshooting on these devices, we have various warnings and faults and other informative codes. Some of them are pretty cryptic, I know, and difficult to interpret, but all of the fault codes are listed in the instruction manuals. And so if you have a unit that's in fault or in warning, you can go to the instruction manual to interpret what that code actually means and take remedial action based on that. So on the Series 3000, this comes directly out of the instruction manual. We recommend a visual inspection every 3 months. Recommend that we do perform a functional gas test every 6 months. Typically, this gas test is a bump test, and we use a bump test to determine whether or not the Series 3000 needs to be recalibrated, rezeroed and recalibrated. Generally, if you are more than 10% of the full scale reading when you actually apply gas, if your full scale is 100, whatever units, and you provide 50 as a test gas level, if your reading is between 40 and 60, that's considered to be acceptable. Because you remember the gas cylinder also has a tolerance, and so generally if you're within plus or minus 10% of full scale, that's generally considered a valid test. On the XCD, it's much the same. Typically, we're going to do a 3-month visual inspection. Electrochemical cells typically have shorter lifespan than, let's say, a catalytic bead sensor. And so usually we can get greater than 24 months out of them. I think the warranty period for toxics and oxygen is 2 years. Catalytic, we use terminology here called Pallister that comes from England. It's basically catalytic beads. And we typically get 3 years operating life out of those. Again, that's going to be subject to how much gas the detectors are seeing. And on catalytic bead sensors, since we're actually burning lower explosive elements, if those chemicals have, or those compounds have, a poison attached to them, the catalyst can't burn those off. And so what that ends up doing is it ends up blocking what's called one of the active sites on the actual Pallister. And if you get enough of those active sites blocked, you're not going to be getting any gas detection. You'll basically have 2 reference beads. So it's important to challenge those combustible gas detectors every 3 to 6 months. Non-dispersive infrared affected by the same poisons that are associated with catalytic bead sensors. NDIR sensors do not interact with the gas. We're not combusting any material. We're not on the electrochemical cell. The target gas will diffuse through a hydrophobic membrane into the electrolyte, and that causes a current to occur. That also consumes a little bit of the electrolyte. So we don't have any sensing element consumption with NDIR. So typically we're going to be immune to poisons that affect electrocatalytic bead sensors, and therefore have a a longer typical lifespan. Yeah. So for the X and X, the previous slide was XCD, right? Yeah. So for the X and X, I think I have a couple of slides on this. Nope, this is the last slide. Reducing the risk of ignition hazard is kind of important. One of the things we do recommend, and I talked about this previously in the presentation, is to take a portable gas detector with you into the area when you're going to be replacing or performing other maintenance. You want to ensure that the area is free of hazardous gases. Um, Additionally, when we're replacing sensors, we always recommend that you power down the instrument. On the Rayguard 2, I know that you don't have to completely remove power from the transmitter, but you do have to make that selection that allows you to change the sensor because it removes power from the intrinsically safe barrier. So take care handling sensors. Try not to um, put yourself in contact with any corrosive elements that might be out there. Um, when a sensor gets replaced, you just can't just throw it away. A lot of this stuff is considered hazardous waste, especially the electrochemical cells. And so those need to be disposed of properly. And there are instructions in each of the manuals on how to dispose of electronic and hazardous contaminants correctly. I could read from the rest of this slide, but I'm starting to run out of voice. So I'm going to go ahead and end the presentation here and ask Mike if we have any questions.
Charles, we do not have any questions yet, so we'll wrap this thing up. And as we're wrapping up, if anybody has any questions, please just type it into that chat tool. Charles, thank you very much for your presentation. If there are any specific application questions or further questions on how to maintain gas detection, feel free to give us a call at 800-9-LESMAN or 800-953-7626. If you don't know your account manager, feel free to ask for me, Mike D. Lecluse, and I'll make sure you get taken care of. We do have somebody on staff that is a product specialist for gas detection equipment. So if you have questions, we can typically get John to get with you and get them answered. He's been around this stuff for 25 years and knows it very well. If you want to know more about the technologies we supply, all of our webinars are posted both on our website and on our Lesman Instrument Co. YouTube channel, so you can get access to the previous two presentations there. If there are topics that you would like us to cover in future webinars, please just send me an email with the subject. We have access to lots of product and process specialists, so let me know what you'd like covered just by emailing me at miked@lesman.com, and I'll pull in the right resources. Charles, we still do not have any questions, so I think we can go ahead and wrap it up. Again, if you have any questions, please just feel free to email me, and I'll make sure that you get taken care of. Charles, with that, let's go ahead and end the presentation. Thank you very much.
Thank you, Mike. Thanks for the opportunity. Take care, guys.